Boys, today we're looking at graphing number patterns. So last time we looked at being able to find a point, a coordinate on the number plane, and today we're going to be graphing on number planes, graphing number sequences or number patterns on the number plane. So let's just start by considering this number pattern here in front of us. 2, 4, 6, 8, 10. I hope you can notice that each time in this number sequence as we go from one to another, we plus on 2 as we go, and that continues on and on. Now we can write this number pattern in a table where we've got the number in the sequence. So this one here is the first number in the sequence, the second one, and so on. So the first number in the sequence, what value does it have? The first one, well, it's the value of 2. The second number in the sequence has a value of 4. The third number in the sequence has a value of 6. The fourth, 8, and the fifth, 10. So we can express this number sequence in a table. Each of these sets of number and value, like the first one, 1 and 2, that also can be considered as a coordinate on the number plane. The coordinate 1, 2, where 1 is the x value and 2 is the y value. And so we can actually plot this sequence of numbers onto the number plane. Now I've just put the first quadrant of a number plane down here on the bottom right. And so I can just plot these points, the point 1, 2, the point 2, 4, 3, 6, 4, 8, and 5, 10. And you can see those points form a sequence and a pattern that goes up by 2 each time and forms a nice straight line. So we went from a sequence of numbers or some sort of number pattern to graphing it. Let's consider this situation. There was a guy named Ralph, and Ralph, he liked to sell chocolates. Now, he sold chocolates for $3 each. And these chocolates, aside from being delicious, they earned him $3 per one that he sold. So if he sold one chocolate, he'd make $3. If he sold 2, then he would make 3 plus 3 would make $6. So you can see I'm starting to form a sequence of the amount that Ralph earns, or the money he makes, after each chocolate he sells. So if he sells another one on top of that, that's going to be another 3 on top of 6, which is 9. 4 will be 12. 5 will be 15. And now each of these, of course, if we look vertically, again is a set of coordinates that we can put on a number plane. So 1, 3. We can see that we could graph the number N sold compared to the money he makes, or his income. So I stands for income. So let's look at how we could graph that. Here's the number sold and how much money Ralph makes, his income. If he does 1, he has 3, 2, 6, 3, 9, 4, 12, 5, 15, and so on. And in fact, this sort of forms a general sort of rule here of Ralph's income and how much he earns, which we can put a line through, because that is going to keep going. The more he sells, the more money he's going to make. Now, what's worth considering is, what's the rule that's linking? Like if I told you that Ralph sold 500 chocolates, how much money would he make? Well, hopefully you can see here that each time it goes up by 3. So the money, or the income he's going to make, is going to be 3 times the number that he sells. So if he sold 5, 3 times 5 gives us 15, 4 times 12 gives us 15, so that rule works for all of them. Let's consider a couple of geometric patterns. So from a geometric pattern, we can form an algebraic rule that describes the relationship between two variables. This pattern can also be graphed on the number plane. So we're going to have a look at a pattern here and see if we can get that on the number plane, get it plotted. So let's have a look at this one. We've got some squares and some sticks. So this is the first part in the number sequence. That's the second one, the third, and the fourth. So in the first one, the number of squares is 1. In the second one, it's 2. See there, it's 1. This one, it's 2, 3, and 4. And now, how many sticks are in each? So if each of the sides represents a stick, there's 1, 2, 3, 4 in the first one. There's 1, 2, 3, 4, 5, 6, 7 in the second one. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 in the next one. And there's, if I take that original figure, I just got to add 3 more on, so it's going to be 13 in the fourth one. Okay, so now we've got to plot these on the axis. We're going to see what we get. We'll get 0.14, 2, 7, 3, 10, 4, 13. Hopefully you can see there. If we put a line through those, it's going to form a straight line. If we joined up those points, you'd be able to see we get a straight line that's joining them. So there's sort of a linear relationship in this sequence. Alrighty, so what is the relationship between these? How do we get from this top row of squares to the second row of sticks? Well, each time we've sort of got a plus on 3. So as you add a box, you sort of have to add on 3. But there's more to it than just timesing by 3, because the difference between these is not just timesing the top by 3. You actually need to do 3 times the top and then plus on 1 more. So 1 times 3 will give us 3, plus 1 is 4, and that continues. So the number of sticks, n, is going to be equal to 3 times s plus 1. So how many sticks are needed to form 20 squares? If I had 20 squares, how many sticks? Well, I'd have to do, the number of sticks would be 3 times 20 plus 1. So n would be equal to 61. How many squares are formed by 40 sticks? To do 40 sticks, you would need, if you had 40 sticks, we'd now have to find how many squares. And so 40 would be equal to 3 times by s plus 1. So to solve this equation, we'd subtract 1 on both sides. So we get 39 equals 3 times s. Divide by 3 on both sides. You would get 13 equals s. So s, the number of sticks would be, number of squares rather, would be 13. I'm going to leave it there. The main goal for today was to be able to convert some sort of pattern. So take a pattern and put that pattern onto a graph. So if you can make that, that is your goal for today.